question 2. So we need to show that the equation g of x equals 0 can be written as this. So g of x equaling 0, so this equaling 0. So let's take the x and the minus 6 to the other side. So e to the power of x minus 1 equals 6 minus x. We've done that by minusing x and adding 6 to both sides. Now, if we learn both sides, we get learn e to the x minus 1 equals learn 6 minus x. And so using the power rule, x to the minus 1 coming to the front, x to the minus 1 learn e to the, learn e equals learn 6 minus x still. Remember, learn e is just 1. So we've got x minus 1 equals learn 6 minus x. Then add 1 to both sides, x equals learn 6 minus x plus 1 as required. Now, iteration, very straightforward. Don't overcomplicate this. All this is telling us is the next term is this, where we substitute the previous term into here. So to find x1, we're going to substitute x0 into this. So for x1, we substitute x0 being 2 into this. Using a calculator, it gives us this. So this is x1. Now to find x2, we're just substituting x1 into the same formula, and to find x3, we're substituting our x2 into the formula. So there's our x1, our x2, and our x3. Now very similar for part C, really. By choosing a suitable interval, show that alpha equals 2.307 is correct to 3 decimal places. So what we do, we take the upper and the lower bound of 2.307. So our lower bound is 2.3065 and our upper bound is 2.3075. We substitute both of these into the function. This is our function. So we substitute this into our function, which I've done here. Now when we substituted 2.3065 in, we got a very tiny negative number. When we substituted 2.3075 in, we get a very tiny positive number. So the sign has changed. We've gone from a negative to a positive, so it stands to reason that the root is somewhere in here, where it actually equals 0 is somewhere in here. So a sign change, therefore a root between these bounds.